Okay, so for this problem, we want to find dy by dx when e to the 3xy is equal to x. Now, a couple of things you have to spot with this one. You've got an x times a y, so it's a multiplication, so we should be thinking product, and therefore we're going to be using the product rule. And we've got an x variable times a y variable, so two different variables there. So we're going to need to use the rules of implicit differentiation. And actually we have to spot a little bit of a trick for this one to make it a little bit easier for ourselves. Is actually we can rearrange this a little bit to get rid of our exponential by taking the natural logarithm on both sides, such that we can say that the natural logarithm of e to the 3xy equals the natural logarithm of x, and our natural logarithm exponential the inverses of one another, so we can get rid of those. So we can say that 3xy equals ln x. And that's going to make things much easier for us to differentiate this expression. Now, we've looked in previous questions at how to differentiate 3xy. It is a product rule question, but actually we can say it is 3 times our general expression x dy by dx plus y. You can have a look back at our previous videos to see where we've looked specifically at this example and the simplified version of differentiating xy using the product rule. And if we differentiate ln x with respect to x, that gets us 1 over x. So all we need to do at this point is a little bit of rearrangement. Well, we're timing by the 3 there, so we can move it over as a division. So x dy by dx plus y equals 1 over 3x. Move the y over, x dy by dx equals 1 over 3x minus y. And then finally, divide by the x. So dy by dx equals 1 over 3x squared minus y over x. Alternatively, you could combine those together into the same expression, multiply that by 3x, so 1 minus 3xy all over 3x squared. Okay, either of those forms would be fine, and you would get the marks for those in an exam. And that's what we get for dy by dx when e to the 3xy is equal to x.